Hello, everybody, and welcome to this is the week 5 fieldwork supplementary sort of lecture or seminar and workshop. And this week we're going to be thinking about how we go about locating and recording archaeology. So in previous weeks you've talked about how we identify it, maybe how we interpret it in terms of sequences and things like that. But we also need to know exactly where bits of archaeology are, because unless we can locate them within actual 3D space, they're not as useful to us as they might be. So this week we're going to be talking about how we actually go about locating archaeology. So I'm going to tell you a little bit about one of my projects that I run at a site called Windy Hill, and then once I've introduced you to the site and given you some of the problems that we face in terms of locating and recording the archaeology there, I'm going to pass over to Dr. John Piprani, and he's going to lead you through a practical activity, which is all about locating archaeology using 3D data. So in this workshop, as I said, we're going to introduce you to the site of Windy Hill. I'm going to tell you about the main research aims and a little bit of background, and then I'm going to kind of tell you some of the different options we had in terms of when we got there, what kind of different ways we could go about investigating and excavating the site. And we're going to have a focus on particular types of archaeology and particular ways in which we might go about recording the archaeology. And this, in part, sort of shaped the way that we decided how to go about doing our excavation. Then I'll set out the methodology that we chose and explain why. And then we will end with kind of a list of things that we know we wanted to do. So that was right at the start of the project. But it's all well and good saying what you want to do, but obviously the big question and the important thing for you in developing your skills is that we need to think about how we actually go about doing it. So I'll leave you with a list of sort of questions of how do we do this, that, and the other, and Don Piprani will be in, and he will tell you exactly how we go about doing it. And there's a practical element at the end as well. So we'll take you through the whole sort of range from project conception all the way through to sort of completion. So we're talking about the site of Windy Hill, and this is where it is. So Manchester is down here in the bottom left-hand corner, and this is all orientated north. So here's Rochdale and Bury to the north of Manchester. And if you've ever taken the M62 out of Manchester, going over the Pennines, you will know after you get out of Rochdale, you go up a series of large hills, and then towards the top, just before you reach an area where the motorway splits around an old farmhouse that's in the middle of it, you will know that you go up and there's a big hill on your right-hand side, and it's got a big radio mast, and that radio mast is the Windy Hill transmitter. So in this red box here, that's this map just here, and you can see blue line is the motorway. And this is pretty much the summit up here. So we're right on the top just here. This is Saddleworth Moor. And this area outlined in red is the field that we had access to at Windy Hill. So these are all field boundaries. And on this edge, it's actually a stream that delineates the northern edge of the field. So that's where we were. Let's have a look at this. Windy Hill is pretty open and pretty rugged. Here we can see in this photo, oh well, on the left we've got some lovely sheep, and on the right we've got there the motorway climbing its way up and heading out towards the east. It's a large field. We've got a lot of topographic features. So you've got hills, we've got it all sloping down into the stream at the bottom there. There's sort of like wetland pockets down here as well, which makes moving across it quite difficult. All of this means that it hasn't got a lot of landmarks. So you find that the actual field is massive without any real clear idea of exactly where you are in most of it. So it's difficult to get your bearings as to exactly where you are. And it's also very rugged, which means, you know, some of the things that you might do on another site, so put a little post in the ground or something like that, and then you know where you are. It just wouldn't work in this site because it's so big and it's so rugged. You've got like knee-deep grass and wetlands and bogs and things like that. So we needed to think about exactly how we were going to go about recording where our archaeology is. Otherwise, all we'd be able to say is it's in this field. And that's not really that useful. So we had to think really carefully about it. The field itself has actually got a lot of exciting and interesting archaeological potential. So we'll see on this picture just to the right here, we've got a number of different archaeological features that are marked in different colours. In green, down at the bottom, we have a historic trackway, which at one point was one of the main trackways that was crossing the Pennines from east to west. And that runs sort of in and out of the field boundary as it runs along. We've got a derelict farm, that's this little white rectangle just here, and remnants of the farm field systems, they're also in white there. We've also got other earthworks. We've got a larger bank and ditch system in red, which we're unclear as to whether it relates to the farmstead or maybe an earlier period of activity. And then this is the top of the hill just here. We have two visible concentric ditches running around the sort of northwestern side of the hill, which we thought could quite easily be later prehistoric. But the thing that we were really interested in was the archaeology that was recorded in the 20th century here on the top of Windy Hill, because we've had a number of excavations and a number of flint collectors, and they're finding a lot of stone tools that are dating to the Mesolithic. So that is the period after the end of the last ice age. So it's running from around about 9,600 all the way through to 4,000 BC. And this is the last period in Britain where we have hunter-gatherers moving around the landscape. So it looks like that we have potentially quite intensive moments of occupation on Windy Hill by these hunter-gatherer groups. And that's what really interested myself and Hannah Cobb, who is the other director of the project, because we're both Mesolithic specialists. So that's what we really wanted to focus on. So since the 1920s, there have been two small excavations on the hill, both of which have found small collections of stone tools. And flint collectors also walked this area for decades. And so they've found, again, small collections of stone tools. The hill has occasionally suffered from sort of moorland fires, and what that does is it burns the peat off the surface and it reveals the mineral soil underneath, and that's where these lithics are. So in these areas where the peat has burnt off, we have these little erosion patches. And so flint collectors go out after fires and they sort of identify and recover these lithics from these areas. So we know that there's activity on the top of the hill, but we don't have a really sort of like a full picture of what was going on there. So the question is here, how exactly do you approach a site like this? The hill's quite big. It's well over 100 meters across in both directions. How would you think about excavating it? To my mind, there were maybe three key ways we could approach it. The first that we could do is to try and locate where those previous trenches were, because we know that they have archaeology in them. So we could find those trenches and dig next to them and see if we can find more. So that's option one. Option two would be to use the knowledge of one of these flint collectors. So Stephen Poole, who was a member of the excavation team, the project team, he has been collecting on Windy Hill quite literally for decades. And so he's got a really good idea of where particular places, particularly these erosion patches caused by wildfires, where the flint is coming from. So he can identify a number of different hotspots. So option two would be led by Stephen's knowledge of the site and maybe go and investigate one of these hotspots. The third option would be to undertake a systematic sample of the hilltop. So dig a representative sample all across the hill. So not focus in one place, but actually dig small holes across the entire hillside. And that's what we would describe as a systematic sample. So take a moment here. You might want to pause the video for a second and have a think, which one of these would you do yourself? Okay, so if you've decided which one you would have done, I'm going to tell you what we did. In the end, we decided to do a systematic sample. So that is dig a representative piece of the hill across all bits of the hill. And we did this for a number of reasons. First of all, there's material that's already been found at that site, but they've either been found through very small excavations or these small erosion patches caused by fires. So we know that there are things in these little spaces and little points, but we don't really understand how it all fits together. Have we got activity across the whole hilltop? Have we got little pockets of activity scattered around the hilltop? So to understand the material we already have, we need to try and understand it in context, or to put it in context. In order to put it in context, we need to understand the hilltop as a whole. So that's the first reason why we decided to do a systematic sample. Secondly, archaeology, and this is more of a methodological point than one that's particularly related to our project specifically. Archaeology should be systematic. We're not treasure hunters. The idea of finding somebody's trench and just sticking our trench next to it has a bit of a treasure hunter vibe about it. So we really wanted to try and understand the site as a whole. And thirdly, and tied into that, we were aiming for this project, and we still are, we're aiming to go back and keep on digging this year in, year out, potentially. So it makes sense to try and characterize the big scale first, so the whole hill, and then once we find pockets of activity, we can focus on them in more detail. So this is all about trying to get a representative picture of the site, because this was the first year that we were excavating it. We needed to get a good idea of where we were. So what that looks like is, to get a systematic sample, we decided to use test pits. So whether you're finishing your first year or your second year of your degree, you should have come across test pits in the lectures for doing Archaeology 1 and 2. A metre by metre square test pit, which, if we want a systematic sample, we need to place them logically and systematically across a particular area. So what we did was we planned to lay out a 10 by 10 grid over the entire hilltop. And then within each 10 by 10 grid, we would, to begin with, excavate one 1 metre squared test pit. And so 1 metre square test pit in a 10 by 10, that's 1% of that 10 by 10 metre grid being excavated. So if we dug a test pit in every single 10 by 10 metre grid square, that would give us a 1% systematic sample of the hilltop. So this was the first way in which we were going to try and create a systematic sample. And then once we did all of those, we could then go back to that grid again and maybe decide to put another test pit in each grid square, again trying to place it in the same place to get a 2% sample. And so you could expand your investigation like that. So this is what it looks like. This is one of our 1 metre square test pits. Thankfully, they weren't very deep. It was just a thin layer of quite degraded peat and down onto the mineral soil, which the hill itself is made of. And here you can see, this is an aerial photograph of the field. So there's the stream and the field boundary just here, and the historic trackway. And this, in the red box here, that's this area just here. You can see the contours show that we're on the top of the hill. This is our 10 by 10 metre grid squares. So we've got, so it's 100 metre square Each of these is a 10-meter square, and each one of these tiny black squares in the top left-hand corner, so that's the northwest corner of each 10 by 10 meter grid square, that's our small 1 meter test pit that we were going to excavate. So that's how we go about doing our systematic sample. So all that's great. So we know if we do that, we have a systematic picture of the site, albeit at 1%. It's not very high resolution, so it may not give us all the information. In fact, it definitely won't give us all the information we need, but it gives us a basis to then develop future investigation and excavation. So that's great. So we're now digging our test pits, and we know that this is a systematic sample. But once we start finding artifacts in our test pits, we need to be able to locate where these artifacts have come from, because we can't just say, oh, all of these artifacts come from Windy Hill, because we've got no idea if it's one big collection of artifacts or whether they're from completely separate events. You know, these events, if they're split out spatially, so on different sides of the hill, they may also be hundreds, maybe even thousands of years apart in the Mesolithic. So it's really important that we are very clear about where different artifacts come from. So what we could do is we could give each test pit a unique number, and so we do give each test pit a unique number, and we could say all of these artifacts come from test pit 1A, and these in this bag come from test pit 3B, and so you know which meter square they come from. So that's a good way to do it, but it's still quite a coarse tool, because you only know which meter square the artifact comes from. You don't know any more detail. And actually the detail of exactly where these tools come from can be really, really useful, because when we look at sites such as Mesolithic sites, but also Paleolithic sites and later prehistory like the Neolithic, we are really interested in looking at what we describe as scatters of material, particularly stone tools. And this is where people sat and worked stone, so took big lumps, big cores of flint and worked it down into sets of artifacts. And there's also lots and lots of waste material known as debitage. So we want to look at these scatters and we want to identify what different types of activity is going on in different areas. So that means we need to look at the specific place of each single artifact, because we can look in a scatter and say, over here in this part of the scatter there are lots of, say, blades. So that might suggest that they're using them for cutting. So it might be for processing plant materials, it might be for butchery. But over here, we've got lots of scrapers. So maybe that's about woodworking or about processing hides or something like that. So knowing exactly where each artifact is allows you to think about what's going on in a particular scatter. To do that, it means we need to record the exact location. So within a meter square isn't enough. We need the absolute pinpoint location of each artifact. So this is an example of a plot where each flint tool has been 3D located. And you can see that they're not equally spread out across the site. We're getting these little really intense clusters. So there's an intense cluster here. You can see little pockets here, but then there are other areas with far fewer lithics or stone tools. So this gives us an idea about reconstructing different areas of activity, different types of activity that are going on as well. So this kind of 3D recording is really important for sites where we're dealing with things like stone tools. So this is great. We know what we need to do. We know that we need to set out a large 100-meter square grid over the top of the hill, and we need to split that into 10-meter squares. And then within each 10-meter square in the top left-hand corner, so the northwestern corner, we need to have a 1-meter test pit. That grid needs to be aligned with the national grid. So the national grid is the grid that goes over all of Great Britain, and that's how all of our maps are produced. So we need to align our grid to the national grid, so it fits in with national grid coordinates. We also need to record the precise location of finds, exactly where they are. Now, this is all great. We know what we need to do, but we haven't yet discussed how we go about doing this. And this is where the practical skills-based portion of this workshop comes in, because the way we go about doing all of those activities is we use something called Global Positioning Systems, or GPS. And this is a piece of kit that most excavations will have out with them. And they use this to plot out trenches, to record the locations of finds, to plan features and other bits of archaeology as well. And it's incredibly important. It produces lots of data, and then we use that data to plot our archaeological finds and our archaeological features in 3D space within computer programs such as GIS, Global Information Systems. So to talk you through all of this, I'm going to say goodbye now, and I'm going to hand you over to John Piprani, who's going to tell you about GPS and get you to work through some real GPS data so you can start plotting this 3D data on maps and start recording your archaeology in a digital way.
So first of all, what is a GPS?
GPS stands for Global Positioning System.
The GPS we've got is like a large mobile phone, and it uses satellite data to coordinate and identify where we are in the landscape at any point in time. So if it can get access to 4 satellites, then it can tell us within a meter or 2 meters of accuracy where we are in the world. So that's great if we're using it for navigation purposes and we're moving from A to B. But for archaeological purposes, we need to be more accurate. If we want to use it to locate ourselves, our site or a find or a trench, then we need to have better accuracy than 2 meters or 1 meter even. So the GPS we've got is made by Leica, and it's called a sub-meter GPS. In other words, sub, less than a meter. And this GPS has got a correction system built into it. So if you can get satellite signals and a mobile phone signal, you can then access the correction system, which will give us accuracy down to around about a centimetre, depending on satellite signal and mobile phone signal. So that's really useful, because then we can use the GPS to record points up to a centimetre, so whether it's a find, corner of a trench, and we can plot it on an ordnance survey map and record that to produce in reports or summaries of the site.
So if you're going to borrow the GPS from the university, what you'll be borrowing is this pole, an extendable pole, and this red box with the GPS and associated things in it. So the first thing to be aware of when you're using it is make sure that it's this way up. So it's got some writing here, Xeno 20, just make sure that's the right way up. If the writing's the right way up, then when you open the box, everything's in place, nothing's going to fall out. So in the box, we've got 3 main things of interest. We've got, first of all, the GPS itself, and it's on a bracket that will allow us to attach it to the pole. The second thing is the receiver. So this is the the thing that collects the satellite signals, and we're going to attach that to the top of the pole. The third thing of use is the cable, and the cable links together the GPS and the receiver that sits on the top of the pole. There's a couple of other things in here that you probably won't need whilst you're taking readings. First one is a download cable, and the second one is a spare battery in case the GPS runs out of charge. Alright, so these are the components. The way I tend to assemble it, first of all, there's a screw thread on the end of here, and there's a screw thread in there, and I attach the receiver to the top of the pole. So the next bit is to attach the GPS to the pole. There's a bracket on the GPS and there's a corresponding bracket on the pole. Insert the GPS into it. The main thing at this stage is to make sure it's at an angle that you can work with, that you can see easily while you're working, and then tighten it up. The next thing I do is to extend the pole. So the poles, we tend to use the pole at a height of 2 meters. Once it's marked on the pole, once you've got it on there, if you turn the pole, it should click into place. So essentially, we're always using the GPS at the same height. When the GPS receives the signals, it's programmed to identify a point 2 meters below the receiver. So if we have it at a height other than 2 meters, the readings are not going to be correct. Then, final thing I do is to attach the cable to, first of all, the receiver, and I tend to tuck the cable underneath there to keep it out of the way, and this bit goes into the GPS. Finally, close the box in case it's raining. So, in order to start making some recordings, what we need to do is decide what we're going to be recording. And initially, what I'd like to do is the edges of the trench. So Stephen's put in the points for 2 meters. So if we can do that one. Stephen, you know the other side of the trench? If you could put a couple in, we've just got something we can locate. So if you take that out and place this where it needs to go. Right, and then if you can concentrate on getting the pond level correct. And just let me know when you're ready. Okay, so it's measured it. So we're going to do a point. Okay. So we've measured that point now. Okay. So I'll do the next one if you want to press the button when it's ready. So I'll stick that one back in when you lift it up. so now you've seen the points being recorded, we're going to use another piece of software to process that data and to produce a map. So the new software that we're going to be using is called, or the acronym is GIS, Geographical Information Systems, and we're going to use a free version called QGIS. So when you get your data, you'll be looking at the data that I recorded, and at the site I recorded shapes, so the shape of the trench as well as the shapes of a number of significant rocks and some points which represent find spots where lithics were removed. So you'll have points as well as shapes. So to process the data, you'll have to download the QGIS software. The link to download it is on Blackboard, and there's also a screenshot on here. Because it's free software, there's a number of different versions, and it's better for us to download the version that's listed here. It's more robust, and that's useful for us. So when you go onto the QGIS website, if you follow the instructions and then install the program. So once you've downloaded the QGIS software, there's also on Blackboard two files with data in them. The first one is data to produce a base map. So it's to allow you to locate the second lot of data, which is the points and shapes recorded at Windy Hill, onto a map. So you'll need to download both the base map and the 3D data recorded from Windy Hill. There's a screenshot here that shows you whereabouts they are on Blackboard. And when you save them, it's useful to save them somewhere like the desktop so that when you start to produce your map, you know exactly where the data is. So once you have downloaded QGIS and you've got your two sets of data, we're going to go through the process of uploading the data into the software to produce some maps. And I'm going to run through that process with you now. Okay, so the first thing we're going to do is upload the data that we've got on Blackboard and put it onto QGIS. So first things first, open QGIS. So once QGIS is opened, you're presented with this screen. A couple of things to check. First of all, we're going to use British National Grid, and the code for that is EPSG 27700. So just check in this bottom right hand corner that that is what it's set to. If not, open the dialog box and plug in EPSG 27700. Open up the project, and then we want to go to layers and add a layer. And first of all, we're going to add a raster layer. So we're going to add the background map that we're going to put the trench onto. So if we use these three buttons, it allows us to search for the data. So wherever you've downloaded the data, that's where you need to head for. So mine's in Windy Hill, QGIS data. You will have one tile. I've got a selection of tiles, so I need to find the relevant tile. The tile we need is SD91 SE. So I want to open that particular tile, and then I want to add it to QGIS. It presents me with these options. OK. What I also need to point out is that because we've added data, it's changed the geographic system to unknown. So if we open it up, and we can change it back to EPSG 27700. Then OK, and we can close this dialog box. And what we can see is it's added the file on the left hand side, and we've got a map of the area that Windy Hill site is on. So far so good. So what we've just done is we've uploaded a raster layer, which is essentially a backing map, onto our QGIS project. So now we need to upload the site data. So we go through the same process again, layer, add a layer, but this time we're going to add vector data. So my understanding of the difference between raster and vector data is that raster data is pixelated, so it's providing an image. Vector data is coordinates, and so it's locating points on a map. So we're blending those two different types of data. So we need to find the vector data. And we're using the data that's got trench, stone and fines. But although we've recorded quite a lot of information, and we need all that information, for this process, what we need to do is take out the shape files. So QGIS is interested in the shape files. So I'm pressing the control button so I can select the 3 shape files that we're interested in, and I'm going to open them and then add them to the QGIS map. So we can see that they've been added: fines, stone and trench. So I can close this dialog box, and it's still on British National Grid, which is perfect. So that's the process of taking the data that we've recorded using the GPS and uploading the selected elements that we need to produce our map onto QGIS. Now we've uploaded our map data and our finds data onto QGIS, we're going to go through the process of making some maps. I'm going to go through the process of making one map, but for your portfolio you're going to need 2. And probably the 2 most useful maps that we can make from the information we've got is an overview map. So perhaps something similar to what we're looking at, where we can see the roads and we can see the site. So we've got the site here and the motorway there and a main road there. So that if we were planning on visiting the site, we've got some idea where it is in the landscape, how to get there and what direction we need to travel in order to access it. So I would recommend that your first map be focused on at least include information such as the site and the roads. However, I'm going to go through with you the process of making a map for the trench itself. So that'll give me the opportunity to show you a couple of the features, and that will allow you to navigate your way around the QGIS map making function. So some of the key things that you'll need to know are, along the top line we've got a plus and a minus sign. The plus sign is to zoom in and the minus sign is to zoom out. Once you've zoomed in and zoomed out, you then need to go back to the hand sign, which allows you to move the map around. So we're on the hand sign at the moment. We can move the map. If I go onto the plus sign and place it above our site, we can change the scale. So we can start to have a look at what we've got. And here we can see we've got a trench, we've got some rocks, and we've also got some finds. Now, because the image is not in the center of the screen, I'm going to go over to the hand tool and going to move it to where I want. So the things I need to think about at this stage, is this the kind of scale that I want my map to be at? If I wanted it to be slightly smaller, I could reduce the scale, slightly bigger. If I want to move it to the center of the page, I can use the hand tool. So essentially, I'm organizing how I want my map to look like at this stage. Once I've got an idea that this looks okay, then how do I go about making a map? So again, along this top line, I need to find the new print layout logo. With any of these logos, if you hover the mouse over them, it tells you what they do. So I'm going to click on create new print layout. And what that's asking me for is to give the file that I'm going to produce a title. So let's call it Trench 1. So now I know what my file is called when I want to retrieve it. Once I've opened the file, what I'm presented with is this print layout for my particular map. Along the left hand side there's a range of, again, logos, and again if you hover over it, it tells you what it does. So I'm hovering over adds a new map to the layout. I'm going to click on it, and then if I go over to the layout and form a space in which to drop my map, then when I let go of the mouse, the map appears. So there's my map of the trench with the finds and with the rocks of significance. But on its own, it doesn't really tell us anything. So there's a number of other features along this left-hand side that we can add to make more sense of our map. And the most obvious one is this one here. So I'll just hover over it, adds a new legend to the map. So let's click on that and decide, I think I'm going to put my legend here. So the legend is simply going to tell us what the different things are on the map. Okay, so it's inserted the legend. It's also inserted data that I don't want. So this SD91SE, if you think back, that's the raster data with all the map information. So that's not relevant to our map, so I want to get rid of that. To get rid of it, if I go over to the right hand side and I untick auto update, then I highlight the data that I want to get rid of. If I go a little bit further down, the minus sign is to get rid of data that I don't want. So now if I go back to the map, we've got a legend that says find, stone and trench. So it tells us what information we're displaying on the map. Okay, so what else can we add that's useful? This logo here, if I hover over it, adds a new scale bar to the layout. So let's add a scale to our map. Click on it, decide where we want to put it. So let's put it underneath our legend. There it is. So there's 1/2 metre, and we know that our trench is around about 2 metres. So that's right. The final thing I'm going to add to this map is a north arrow. This, if I hover over it, adds a new north arrow. So click on it. I'm going to put my north arrow in this corner here. I'm not going to make it too big. There it is. If I want to move my north arrow, I can adjust it to how I see fit. And finally, I'm just going to go back to this right hand side, go down, and I want to add a frame. So I've included a frame. There's options for colour and thickness, so you can adjust it. And the key thing is, for your portfolio, think about how you want to organise your maps. Obviously, we want to give the map a title, and we want to give it a figure number, and then talk about what is in the map. But we can do that within the Word document. We don't need to do it on the map. Well, the key thing is think about how you want to relay the information that you're displaying. So now we've got the layout that we want. If we go to this top line here, we've got a number of options of how we can export it. So we could export it as a PDF if we wanted it as a standalone map. So we could do a series of PDFs, give them to people at the site so they can see what they're looking at. Or because we want to insert it into our portfolio, let's export it as an image. So I'll click on export as an image, and it's going to export it as a JPEG, which is perfect. There are a number of other options, but JPEG is great. I've called it Trench 1. I'm going to save it in my Windy Hill file. Some options as to DPI, so if there was particular requirements for the quality of the printing, you could adjust it here. I'm going to save it. It's been saved successfully. So now I'm going to close it, and I'm just going to check that it's in my file. Okay, so Windy Hill, GPS data, Trench 1, and there's my JPEG that I can copy and insert into a Word document. So if we go back to QGIS and I go to the minus sign and I start to zoom out, I can start now to think about how I want my overview map to look like, so that anybody coming to visit the site can use this to get as near as possible in a vehicle and then on foot navigate the way to the site. So that's your task. Good luck.